that is the line that I'm interested in working with. I need to find the equation of this line. The data points at this point are there, but we're not going to pay any more attention to those things. As was discussed, so we're ready to move on to the next part. We need to find the equation of this line. Okay? As was discussed in a previous video, we want to choose points on our line that are far apart. If I choose 2 points that are very close together and I make small estimations and errors, that's going to make a big difference by the time I get out there, right? If I choose 2 points close together but I miss it by a little bit, by the time I'm out at the end, I'm way off. Okay, so I want to pick points that are far away, because even if I make a small mistake, that error will get spread out over the entire distance and not really matter very much. So I'm going to begin at one side, and I'm going to look for data points. I'll zoom in so you can see what I'm looking for. I'm looking for a place where the line crosses, like right here. At this point, the line crosses exactly on a grid line. So I'm going to mark that point with an X and say, look, that is one of the points I'm going to use. I'm now going to go all the way to the other side of my line, and I'm going to do the same thing. I'm going to start searching, looking for a place where the line crosses. We want to do this as well as we can. That's pretty good right there. That one there. We're going to mark that point. I'm going to continue looking just to give examples of what are other good points. So here's another point. This is pretty solid right here. Okay, I'm not actually going to use this point, but that one's pretty good. It's basically exactly halfway between these 2 points, and it's right on that hash mark. That's not bad. It passes a little bit below, but that's not a bad point. Continuing on. That's a really good one. Right there. The other thing you can look for, and I don't see any of these, but you can look for a place where the line crosses exactly through. That actually might be okay. Where the line crosses pretty much exactly through the center of the box. But you're looking for these points where you don't really have to estimate very much. You can look and know where the point is. So there it is. I now need to find the coordinates of these 2 places. In order to do that, I'm going to use my scale. Here's the point. I follow it down. It's right there. I know from my scale that one box on the x-axis, one box is worth 6.25 degrees Celsius. I am zooming in again. That point is exactly one box before 200. I know that one box is worth 6.25, so I'm going to look and say, okay, well, 200 minus 6.25. So the value there is 193.75. My x value at this point, I'm going to write this down, 1.93, 193.75 is my x value. I now need to find my y value. I'm again going to follow this line back all the way to my scale. It's one box past 1.075. Well, I know the value, one box on the y scale. So I'm at 1.075. I need to add one more box. I know that one box is worth 0.0. Y-axis, I wrote this down. It's here. On the y-axis, one box is 0.00625 on the y-axis. So 0.00625. So I know that the value, my y value at that point, is this. 1.08125. I'm not going to round that off yet. I'll round later. So now I'm going to repeat that exact same process for my other point. This will be an opportune moment to fast forward for a couple of seconds if you like, or if you want to see it, stay tuned. I'm going to use this point way on the other side of the graph, as far away as possible. I'm going to look at my x value. my x value falls 2 from my 0 point, which I do know. I was pretending before I don't know that, but this is 0. I'm 2 boxes before that. I know that each box on my x-axis is worth 6.25. So if I start at 0 and I go back 2 boxes times 6.25, because on my x-axis each box is worth 6.25 degrees, I'm going back, so that's negative 12.5 degrees. My y value, I'm 1 box above 1.000. On the y scale, each box is worth 0.0065. So it's 1.00625 is my value, my y value at that point. I now have both of my points, and I'm ready to calculate my slope. For our equation, for our equation, we're looking for a linear equation. Y is equal to mx plus b. We need to find this number and find this number. Slope, we have an equation. Slope is y2 minus y1, x2 minus x1. I have 2 points. I just found them. I'm going to write them down here so I have ready access. 1 point is this. I don't know why I keep putting a dot there. I'm rebelling against such large numbers. 193.75 degrees C and 1.08125 meters is 1 point. My other point is negative 12.5 degrees C and 1.00625 meters. These are my 2 points. I can now fill these in to my equation. y2, 1.08125 minus y1, both of these are in meters, divided by y2 or x2, 193.75 degrees C minus negative 12.5 degrees C. I pick up the calculator, being careful with my parentheses. I'm going to put parentheses around the top, parentheses around the bottom, punch this into my calculator. 1 point. Careful with the minus there. I went ahead and put that decimal place in there again. Alright, and we find that the slope of my line is 3.64 times 10. Actually, I get one more digit, don't I? Yep. I actually get 4. I get 4 significant digits in this experiment, so I'm going to keep one more. 1, 2, 3. I get 4 significant figures. Times 10 to the minus 4. I find my slope is this. Now that I have my slope, I can take that and plug it in for my slope so that I can go after my b. Y is equal to 3.637 times 10 to the minus 4 x plus b. Well, I have an x and y value. I have 2 of them, in fact. If I knew x and y, I could find b. I can use these points to fill that role. So I'm going to use this one to avoid the negative number. I'm going to plug this in for y, not for y. I'm going to plug this in for x. I'm going to plug this in for y and calculate what b has to be. 1.08125 meters has to be 3.637 times 10 to the minus 4 times 193.75 degrees C. Oh, I left out the units. I will come back to that. Plus b. I can now solve this equation for b. That gives me, I'm writing this down, but I'm just going to do it all on the calculator. Yada yada yada, there are more digits there that I'm keeping in the calculator. Plus b, I'm now going to subtract that whole value off of both sides. Subtracting that off both sides, and that will tell me what b is equal to. And we find that b must be equal to 1.011. Since I get 4 significant figures, I round that off to the thousandth place. I give a glance over at my graph. I'm going to glance over and say, look, does this make sense? Yes, actually it does. And looking at my data table, I actually have a 0 point. According to my data table, at 0 degrees C, my length should be 1.01. I'm only off by 0.001, which is that's a very small error. Okay, so I feel like I'm confident. My common sense check as I go back and look and say, well, what does this come out to? Paying attention to units. Well, this is in meters, so I have to end up with meters over there. B has to have the units meters. Not only that, it's on my y-axis. My y-axis, which I didn't label previously, now I will. My y-axis shows length in meters. The y-intercept is a y value. It must be in meters. On my x-axis, this is temperature in degrees C. So we can go back and look before we write our final equation, look at what that means about the units of our slope. The y values have units of meters. Meters minus meters gives us meters on top. Over, on the bottom, we have degrees C and degrees C. So our slope gives us meters per degree Celsius. Interpreting that, which is our next part. Interpreting the slope, which I'm about to write here. Writing our equation, I have found that length is equal to 3.637 times 10 to the minus 4 meters per degree Celsius times the temperature plus 1.011 meters. This is the equation of my line. I'm going to write it right there on my graph so that we can see it. The units make sense. I have meters over degrees Celsius. If I multiply by temperature in degrees Celsius, the degrees Celsius will cancel out, leaving meters. Meters plus meters gives me meters. I have now completely found the equation of this line. Moving on to interpretation of what these things mean. What does the slope mean? We get this out of the units. Meters per degrees C. It's a positive number. This rod or bar or whatever we're measuring is getting longer and longer. As we warm it up, it gets bigger and bigger, and I'm too close. Farther away. It gets longer and longer and longer. So this number tells us by how much. Okay, zooming back in. This slope, interpreting it, means that for every 1 degree Celsius that we increase the temperature of our rod, the length increases by this amount. Not very much, but a little bit. Now we're going to interpret the y value. Very often our y-intercept is going to be 0. In this case, that wouldn't make any sense. If the y-intercept were 0, that would mean that if you took the object and put it in the freezer, it would disappear. It would go to 0 length. And not only that, but then if you made something negative degrees Celsius, which is very possible, it would become shorter than 0. That doesn't make any sense either. You can't be shorter than 0. So, the way we can interpret this is to say, okay, well, at 0 degrees Celsius, what is the length of the rod? At 0 degrees Celsius, it should be 1.011 meters, And we confirmed that pretty much on our data table. That is in fact true. If we go in and look, okay, there's 0, and sure enough, it's only off by 1 millimeter. We did pretty well there.